Oops, sorry. You got it. So 0 causes division by 0. So I have x is equal to 0 here. So hands down, now I'm going to check if that is on the interval. So my interval here is 0 less than 0 less than 1. Is that 0 on the interval? No. So it's not on interval, which means I can just ignore it and move on to the next thing. And the next thing is 2x minus 1. Is there any division by 0 here? You got it. There's no division by 0, so I can conclude that this is continuous everywhere. And I don't have any points to worry about there. So from my step 1, I only got that one discontinuity at -1. Am I done with this problem? No. Now I move on to step 2. What are my, you got it, Mikhail, my breakpoints? What are my breakpoints here? You got it, guys. I have 2 of them. I have 0 and 1. And now at the breakpoints, I want to check all of these things that show up in my limit definition. So I'm going to start with x is equal to 0. And I want to look at each of those things. So I'm looking at the limit as x approaches 0 from the left of my function. Okay, I want you guys to take a second. Tell me privately in the chat, do I go to the first function, the second function, or the third function? Careful, I'm doing 0 from the left here. Which function should I go to? 1, the top one, 2, the middle one, 3, the bottom one. Okay, so most of you are telling me the first function, but a couple of you have said the middle one, a couple of you have said 2. Remember, 0 from the left means values that are smaller than 0. So if I look, the top is x less than or equal to 0, and the bottom is 0 less than x. So if I want values that are less than 0, I'm definitely going to my top function. So that's 0 from the left up there. So if I'm like, where is -0.1? I'm like, oh, hey, that's the top. So that brings me to the top function. So I replace 5 over x plus 1, and then I plug in 0, and I get 5. And then I'm going to do the limit as x approaches 0 from the right. Which function am I going to for 0 from the right? Again, tell me privately in the chat. Which function am I going to for 0 from the right? 1, 2, or 3? All right, good job, guys. I'm going to the second function. So I'm like, that's the limit as x approaches 0 from the right of -3x squared plus 5x over x. And what happens when I plug in here? I get 0 over 0. So that means I'm not done, right? That means I have to actually evaluate this thing by factoring out that x on top and canceling. So I do that, and I end up with this is equal to 5. Am I done with this problem? No. So I got that my left-handed and my right-handed limits are the same. What else do I need to do here? Evaluate f of a, in this case f of 0. Which function do I go to for f of 0? Good job. So I'm like 5 over 0 plus 1 is equal to 5. Are all three of these things equal to each other? Yes. So what's my conclusion about x equals 0? You got it. It's continuous at x equals to 0. So we can say here, continuous at x equals 0. Even though I got that 0 over 0, which often represents a removable discontinuity, all three of my things were this equal to each other. So it wasn't a removable discontinuity, it was continuous there. Now what else do I have to do to finish this problem? You got it, Marina. Good job, Yasmina. Yes, Gwen. So here we're going to check 1, and that's 0 from the right, but this is also going to be 1 from the left, and this will be 1 from the right. Because remember, 1 from the right means values that are bigger than 1, and that is specifically what that interval tells us, x greater than or equal to 1. So we're going to go here. Is this confusing with how I'm like trying to squinch this all in here, or can you guys follow? It's okay? Okay, good. All right then, we're gonna squinch more, and now we're going to try x equals 1. So I'm still in my step 2, and I'm doing x is equal to 1. So I'm gonna have the limit as x approaches 1 from the left, which we already said is the top one there, -3, the middle one there, -3x squared plus 5x over x. And when I plug in, what do I get? Good job, guys. I get a +2, not a -2. I'm doing like -3 plus 5 over.
Oh, yeah.
What was that, Ismail?
Oh, I didn't know my mic was on. Sorry. I said, yeah.
Okay. Okay, now I'm going to do from the right, 1 from the right, and some of you have already given me the answer for it. So I'm having this one is 2x minus 1. We already like evaluated that. So this is 2 minus 1, which is 1. Do I need to evaluate f of 1 here? So I could evaluate f of 1, but I can already make my answer. Like I can already make my conclusion. What kind of discontinuity do I have here? Exactly, it's useless to do it. Good job, guys. Some of you already said, good. So x equals 1 is a jump. So this function right here ended up not having any removable discontinuities. It just had an infinite discontinuity and a jump. Are there any questions about this problem? What are some things that could have happened that would have made us know, that would have shown us there is a removable discontinuity? I'll write this up here. When, tell me in the chat privately, when does a removable discontinuity occur? How would I have like known that? Okay, so I have some good answers. If I had that the left and right were equal, so the limit as x approaches a from the left of f of x is equal to the limit as x approaches a from the right of f of x, but does not equal to f of a. You got it. Can that show up at breakpoints? Absolutely, that can show up at breakpoints. Can that, yes, they all exist. Can that, they both exist, rather. Can that also show up in just like in step one at one of the random functions? How would it show up in step one? What would happen when I plugged in step one? You got it. Good job, Sam. I'm gonna wait for a couple other people to answer, see if you guys are all remembering this. Yeah, good job, Yasmina. Not quite, Miguel. I'll give you guys a hint that might help you for those of you that are saying you don't know and that or you don't remember. When I did the limit, where was it? The function negative 3x squared plus 5x over x, if I just had that, that has a removable discontinuity at x equals 0. So look at what happened when we plugged in 0. What happened when I plugged in 0 to that middle function? I did that limit. Yes, Dean. Yeah, good job, Gwen. Good job, Mikael. Yes. And then what did that, so plugging in originally gave me 0 over 0. So I plugged in and I got 0 over 0. And then what happened when I did my canceling out and I evaluated my limit? So it was continuous, but I needed other things to tell me that. Right now, I'm just looking at this one function. I'm not looking at the whole thing. Exactly, I got a value. So another way to recognize an infinite discontinuity is plugging in give 0 over 0, because that tells me that f of a doesn't exist. And then I get a number which tells me that the left and right side are the same. So remember, 0 over 0 going to a number represents a removable discontinuity. Does that make sense? Do you guys remember that now? Is it kind of coming back to you? Okay. Any questions about this continuity question? Can a jump occur in step one? Remember, a jump happens when my left and right limits are different. Can a jump occur in step one? Well, in step one, sometimes we are evaluating the limit. Look, I evaluated my limit. I found values that weren't in the domain, and then I evaluated the limit at those values. I'm gonna wait for a couple more people to answer. You can just guess. You can just throw guesses out there. Okay, so most of you, if it's a guess, are guessing really well. Otherwise, you guys remember this. So the answer is pretty much no. For our purposes, the answer is no. The only time that a jump could occur in step one would be if I had, for example, an absolute value as one of my functions. Where did it go? Okay, hang on. There we go. So like if I had an absolute value function in my step one, then yes, it could occur. But guys, remember that jumps really only occur at breakpoints. So if that's something that you did not still have in your mind, try to like remember, try to get it put back in there. Okay, now ready to move on to question 4? Just gonna read the end of it for you. Justify your answer using the definition of continuity. Did we just remember the definition of continuity up there in green? Yes. Okay, so I can't remember. I think you guys didn't learn this with me. You maybe learned this with Ethan. Am I wrong? So I don't remember. I don't know exactly like how he showed this to you, but I'm gonna like go through and very, very clearly, because on the midterms, a lot of you used pretty poor notation for this problem. So the things that we need to see then, I'm still doing my step 1. Is there anything that might cause division by 0 in either of those functions? Good. So here we'll just say no possible division by 0, which means that I don't have anything to worry about. The answer I get will be my final answer. So then we're going to go on to step 2. And step 2, remember, we're evaluating limits. So I'm going to do the limit as x approaches, what's my breakpoint here? -1. So I want -1 from the left of my function, so of g of x. Which function am I going to for -1 from the left? So -1 from the left, remember that's like -1.1. Yeah, good job, guys. We're going to the first one. The second one is only -1 itself, not -1 on the left side. So that the second one is only for f of -1, or g of -1. So this is kx plus k squared. That one, that -1, am I plugging it in for k or for x? For x. So this gives me -k plus k squared. I need to see that limit exactly like that. Then I'm going to do the limit as x approaches -1 from the right. Which function am I going to? Okay, so I think one of you has said the wrong function so far. So -1 from the right, remember that's like -0.9. Where is -0.9? The first. So this is, again, I'm still at the first function. They equal to each other. Just a question, if I had just immediately done the limit as x approaches 1 of g of x, which one would I have gone to? This right here, when we have the equal sign, that is only for g of -1, never for a limit. For a limit, when we're doing limit as x goes to -1 here, we're saying, look at the left and the right side. I would still go to that first function. That equals is only for g of -1 itself. So here I could just be like limit as x approaches -1, and it would still be kx plus k squared. Does that make sense? All right, remember the closed dot is your g of -1, and that is equals. Good. So now I'm going to actually look at g of -1, and with that in mind, I clearly go to the second question. That equals to 2. Now what do I do? I don't have an equation yet, so I can't just solve for k where. So the left and right-handed limits are already equal to each other in this one. So I'm not setting the left limit equal to the right limit. They already are equal. I'm setting them equal to the function. Good job. So all three of these things need to be equal. So I'm going to go over here and So I'm going to have negative k plus k squared is equal to 2. I am now setting them equal. So I get k squared minus k minus 2 equals 0. Exactly. So I think someone said earlier we need to equate to 0. We're always going to try to get a 0 on the right side over there. And then we're going to factor. So I want two numbers that multiply to give me negative 2 and add to give me negative 1. So the multiplication, the multiplication is negative 2 and the addition should be negative 1. What two numbers are those? Negative 2 and positive 1. Good job. So then what are my final k values? K equals positive 2 and negative 1. And so sometimes we have to go back and look back at the original function to make sure that our k values all make it continuous everywhere. Do I need to do that in this case? I don't. Good job, Gwen. Good job, Dean. Exactly, because there was no division by 0 in my step 1. If I had in my step 1 found possible division by 0, I would have had to go back and check to make sure that my k values didn't cause that division by 0. So my answer is finally just k equals 2 and negative 1. Are there any questions about this? Okay. We're gonna skip 6 because, as mentioned, no limit definition on your final. So we're just gonna skip it. If it's an equal sign, then you don't use it for the limit. Exactly. And we have a piecewise function. So if I want to go back up here, right? So if I'm looking at 0 from the left, when I think about what 0 from the left means, that means some value that's close to 0, but on the left side of 0. So negative 0.1. So to figure out which function I want to use, I'm looking for negative 0.1. Right? And that means I go to the first interval. So it's not the fact that it equals 0 that sends me to the first interval. It's the fact that that's where negative 0.1 is. If I want to do f of 0, I also go to the first function because it has the line under the equal sign, which means equals. Whereas down here, I'm negative 1 from the left and negative 1 from the right. If I'm looking at just negative 1, I need to think about both the left and the right. So I'm where is negative 0.1 and where is positive 0.1? They're both on the first thing. So I go to the first function for both of them. Does that make sense? All right, do you guys have any other questions about continuity? All right, so we have just finished our review of limits and continuity, which means that now we are moving on to derivatives. So we've been doing derivatives for a while now, so I hope we can keep doing them for the whole semester after we start. So hopefully this is still pretty fresh in your minds. So we're gonna start with A, and I just wanna remind you that trig was not on the midterm, and since there is kind of a bias towards the second half of the class, you can expect more of your derivatives to contain trig, Like only 2 of these contain trig, but you'll expect in your midterm for most of your derivatives to involve trig. I'm sorry, Mikael, that's not good. Ah. Nightmare-inducing math class trig. Okay, with that said though, let's just start with the first one. What rule am I going to start off with for the first one? Tell me privately in the chat. What rule is my main rule for A? Product rule, quotient rule, chain rule? Yeah, most of you, good. Most of you are getting it. So it's going to be a product rule that we start with. And for sure there are chain rules in there, but I'm not starting off with the chain rule because I have 2 things multiplied together. So I have like an F times a G. So when I'm thinking of Y prime, basically I'm saying x squared minus 6 cubed prime times 1 minus 9x to the 4th plus x squared minus 6 cubed times 1 minus 9x to the 4th prime. And I just stuck it in my product rule. And at this point, the derivatives that I have left over in the product rule, those involve a chain rule. Tell me what your answer is. I'm gonna give you guys about 2 minutes to work on this and tell me what, in privately in the chat, what your final derivative is. So you should be telling me, typing into the chat, your final derivative when you get an answer. And hopefully the hardest part of this exercise is going to be typing it in and not actually doing it. Perfect, Dean. Wait, almost perfect. No, perfect. Mikhail, almost perfect. You have an itsy bitsy minor mistake. Gwen, you forgot your chain rule. Usmain, I think you're simplifying. You don't have to simplify. Looks good, Yasmina. It's an itsy bitsy minor super tiny mistake, but yes, you did have a mistake. Okay, so hopefully that was the hardest part though, the typing. Billy, it looks to me like maybe you're simplifying. You don't need to simplify. Oh gosh, wait, hang on. I'm trying to read people's and it's Ron, something weird happened with yours, maybe? Okay. Yes. Okay, so some of you have it in simplified form and it's a little harder to check like while the chat's moving this fast. So that's why I'm not telling you because I can't like I could be wrong, Ron. It's just yours was simplified a little bit and then it disappeared while I'm trying to look at other people's. There you go, Mikael, you found it. Okay, oh, oops. Okay. Ah, come back. Don't go. Okay, all right, so most of you got it. Some of you simplified, so that was a little bit hard for me to follow. But we don't need to simplify. It says specifically, you do not need to simplify your answers. So we're just gonna immediately do our chain rule. I bring my 3 down, I don't touch what's inside, I subtract 1, and then I pull out the derivative of the inside. And then times 1 minus 9x to the 4th, then plus x squared minus 6 cubed. I bring the 4 down, I don't touch what's inside, 9x cubed, and then I pull out the derivative of what's inside, which is negative 9. And that's my final answer. So most of you are getting there, but a couple of you had like some minor mistakes. Does anyone have any questions about this product? Okay, Remy, I believe you. Hang on, Dean. I think, wait, yours might have been fine. I'm trying to, I think that maybe I had mistaken mixtures up with Mikael's. Give me a second. Yeah, yours and Mikael's came at like almost exactly the same time, and he had a positive 9 instead of a negative 9. You were fine. Sorry about that. Okay. Now, question B. I'm gonna go and start writing it over here so that I'm not like squunching things. So we're gonna do the square, oh lovely, the square root of x to the 5th. Okay, so now we're going to be doing this, this derivative. Come on. Okay, we're going to be doing this derivative now. Do you think that, yes, good job. Definitely I'm going to start with the quotient rule here. Do you think that I should do a quotient rule inside of my quotient rule here? I have that 2 over 3 x to the 4th. Should I do another quotient rule there? And if not, what can I do instead? So this is definitely not a good problem for logarithmic differentiation because of all of the pluses and minuses, right? It's got like minus 2x plus 2 over 3x to the 4th, and a minus on the bottom. Remember, logarithmic differentiation is mostly good when you have just multiplication and division. So all those pluses and minuses, not a good plan. You got it, Mika. We're going to simplify, we're going to send it back up into the plus form. So I'm just going to rewrite this. And when I'm rewriting this, what's my power of x going to be for the first thing? Going to be 5 over 2. It could just be that it's hard to see that too, but it's going to be 5 over 2. It's really weird that there is a 2 there. When it's 2, normally there's just nothing there at all. Also, like, exactly, like, why on earth would there be a 2 there? So, of course, you're, like, even looking for something else. So, x to the 5 over 2 minus 2x. And then how am I going to simplify the 2 over 3x to the 4th? Tell me in the chat privately what that's going to look like. Because I've seen you guys making a lot of mistakes with that this semester. So I want to see what you guys are thinking right now. tell me how, when you simplify this, so this is what I want to see. When you simplify this 2 over 3x to the fourth, what's it going to look like? So far, not a single person has it right, although it's possible that one person just has some bad notation. Dean, you're the closest. There we go. Good job, Mikael. Okay, we finally have a person who got it. So I'm going to write it. And I think that some of you maybe just were typing it badly, possibly. But that 2/3 is like a constant out front. Remember, if something is in the denominator, it like stays there. So like the constant here is 2/3. The only thing that's moving up is the x. And that x now has a power of -4. And Dean, that was your minor problem. You had a +4. So when I bring it up, it's 2/3 x to the -4. So remember, oh, you did, Yasmina? I'm sorry, I totally missed it. Oh, yeah, no, okay. You had written 3/3 by accident. But that's what I was saying. I figured that yours was probably just an accident. Oh, you corrected it? I didn't see that. Oh, there we go. I see your correction's just really far away from where it actually was. Sorry about that. I didn't like connect the two. My bad. Good job, Yasmina. Okay, so I just want to remind you, the like rule is if I have a over b x to the n, that's the same thing as a over b. The constant just gets stuck out front, x to the -n. Good. And then on the bottom, nothing changes. It's 3 minus cosecant of e to the x. So now I'm going to apply my quotient rule, where this is like my f and this is like my g. So my y prime is the derivative of the top, and I'm just going to do it all in one go. So I bring the 5 over 2 down. I subtract 1, so I get 3 over 2. Then minus 2. Then minus 8 over 3 x to the -5. That's my f prime times g minus, so for quotient rule, it's minus the top Now I want you guys to tell me what the derivative of the bottom is. Again, in the chat privately, what's the derivative of the denominator? This is one of the things that people have the most trouble with trig, so be very careful. You got it, Mikael. Dean, you're missing a sign, but otherwise it's perfect. Yasmina, same thing, you're missing a sign, but otherwise it's perfect. Unless possibly, oh wait, no, never mind, hang on, I see. Yes, that is correct, Dean and Yasmina. I'm sorry, I was just looking at part of it. Mikael, you're the one who has this sign problem. Bella, I think maybe you're using trig or something to simplify. You're using identities. I don't want to simplify it. I just want like the thing. Yes, Gwen, good job. Yes, Jenny. Guys, I just got a new final exam schedule. I'm just going to make sure that I know I confirmed everything, but I just want to make sure nothing changed real quick. Friday, December 11th, 12 to 2, do in the gym. Yes, okay, we're still good. Cyrus, it looks like you forgot a chain rule. But Bella, FYI, yours is correct though. I don't know if I said that. It is right, it's just weird. You will not have to simplify during an exam unless it specifically states so. So like here, for example, it says specifically you do not need to simplify, but like with these problems with like 10 and 11, where we're finding critical values and extrema, definitely you're gonna have to simplify. This exam doesn't have one where it specifically says simplify, but occasionally they do. Okay, all right, so a lot of you have gotten there, so I'm gonna write the answer. It is cosecant of e to the x, cotangent of e to the x times e to the x. And it is okay, so yeah, there's two things. The minus went to the fact that it was being subtracted. So it ended up being 0 minus negative. So the two negatives ended up canceling each other out. So I had like 0 minus negative cosecant of e to the x, cotangent of e to the x. And then my chain rule, I pull out an e to the x prime. So then those negatives right here end up canceling out with each other. And the derivative of e to the x, my chain rule, I have an e to the x pulled out at the end. And now I'm going to divide by the denominator squared. And this is my final answer here. Okay, any questions about B? Let's do C. Okay, so what's my main rule here? You got it. So again, this is going to be a product rule. So I want you guys, actually no, I think I want to make sure that we get through, and I think this one's pretty straightforward. This is just a straightforward product rule. So my y prime then is the derivative of the first. So I have 2 to the 3x plus 1. Remember, when the base isn't e, we have to multiply by ln of that base. So I have an extra ln 2 here, times the derivative of 3x plus 1, which is 3, plus 4, times log base 2 of 4x plus 1, minus 6. So this is my f prime, this is my g, and now I'm doing plus f times g prime. And I made one mistake. Tell me where it is. There you go, Mikhail. Yes, yes, Nina, good job. Yes, Dean, exactly. So what should I do? Good job, Jenny. All right, it looks like most of you are seeing this. I just need a ln 2. Is that good? 100%? You wouldn't lose any points for this? Yeah, Jenny, exactly. You would lose points for this. You would lose half a point for this, because I need brackets around that 4x plus 1. If I put them around the ln 2, that's still wrong, because now that ln 2 is only being multiplied by the 1, right? So it has to be around the thing that has the plus sign in it. There you go. Okay, so D, 5x plus root x to the x cubed plus 1. All right, what's my main rule here? I want you guys to be very extra super careful with your answers here. So far, I've got 2 wrong answers and 0 right answers. No. Nope. I'm going to give you a hint. This is one, yes, Michaela, you got it. So this is one that I said, if you don't recognize how to do it, it's going to be hiding there in the middle of all your derivatives. And if you don't see it, then you're going to do the wrong thing, and I'm not even going to be able to give you part marks. Right? So this is one where you've really got to be careful, and you've got to be trying to recognize it. Yes, Sam. Yes, Dean. Yes, Yasmina. Yes, Usman, you got it. Okay. Do I have x's down here in my base? Do I have x's up here in my exponent? And when I do, what does that tell me I have to use? You got it. You got it. This means that logarithmic differentiation is not just useful, it's actually necessary. So put a big star by this one, because when these show up, you don't want to like accidentally not do logarithmic differentiation. If you accidentally don't do logarithmic differentiation, then that means whatever you're doing is the wrong thing. And I'm not even going to be able to give you part marks. So logarithmic differentiation is necessary. We start by doing ln of both sides. Only if it specifically asks. So can I bring the x cubed plus 1 down to the front, or do I have to separate something out first, like that 5? I bring it to the front first. Remember the difference between like this. This would be separate first because that 5 is out front, it's not to the power. So this one would be separate first. This one is not separate first. I just bring that x cubed plus 1 straight down. So I get ln y is equal to x cubed plus 1 ln of 5x plus the square root of x. Notice those parentheses that I put right here. If I hadn't put them, would it be okay? Those parentheses are necessary. Now what rule do I have? You got it. Now I have a product rule. And remember what we said, when logarithmic differentiation is necessary, we always want to be on the lookout for a product rule because there will be one. So I'm going to do my product rule now. I'm going to have y prime over y is equal to 3x squared ln of 5x plus the square root of x plus x cubed plus 1, 5x plus the square root of x, 5 plus 1/2 x to the negative 1/2. And what is my final step here? Yes, Dean, that could happen, absolutely. I want to multiply by y. And when I do that, should I write y or what? You got it. I'm going to write the function. So 5x plus the square root of x cubed plus 1, 3x squared ln 5x plus root x plus x cubed plus 1 and this is my final answer. Why is it okay for me to not put parentheses around the 3x squared? Oops. Okay, I'm going to ask it again in case you guys weren't paying attention. Why is it okay for me to not put parentheses around this 3x squared right there? Whereas with that x cubed plus 1, I had to. Yes, you got it, Gwen. You got it, Dean. Yes, Sam. You got it. So there's no minus that needs to be distributed. It's one term. It doesn't have addition or subtraction. It's okay, Mikhail, don't worry. So that means it does not need those parentheses. There's no addition or subtraction. Okay, so let's do our last derivative here, e. Tangent to the fourth x squared plus e to the x squared. Would it make sense to use logarithmic differentiation here? Good job, guys. Good. No, it wouldn't make sense. Not because of the trig, though, because of the +1. Remember, exactly, we said when we have like additions and subtractions, logarithmic differentiation, not the best plan. What do I do instead? I have that tangent to the fourth. What did we say we want to do in that situation? You got it, Gwen. Good job. Move the exponent to the front and we're going to treat it as a chain rule. So I'm going to write it like this. I have tangent of x squared plus e to the x squared all to the power of 4 plus 1. You got it. Good job, guys. So now I'm going to have y prime. I bring the 4 to the front. I don't touch what's inside. Excuse me. Tangent of don't touch what's inside. So x squared plus e to the x squared cubed. And then I bring out that inside that I'm taking the derivative of. So in other words, my inside function here is that tangent. Then the derivative of 1 is just 0. So now I have plus 0. What's the derivative of tangent? You got it. So that secant squared, am I evaluating it at x? Should I write secant squared of x? You got it. No, put g of x instead. In this case, my g of x is x squared plus e to the x squared. Then I pull out that g, so in this case, the g is like that x squared plus e to the x squared plus e to the x squared, and I'm priming it. Do I have any chain rules left there? Do, good job. I have this extra x squared up here, so that's going to be one last little chain rule. So I'm going to do that all in one go to have 4 tangent cubed x squared plus e to the x squared secant squared of x squared plus e to the x squared times 2x plus e to the x squared times 2x. And that is my final answer here. So this is one of the things that really trips people up with trig the most, that kind of power. And then also the thing that I had you guys do with the cosecant earlier, where you have the cosecant of e to the x, cotangent of e to the x. All right, are there any questions about this derivative? I'm cutting out. Yeah, I did just say my internet was unstable. Let me just check something. Oh, I'm on my downstairs internet. Oh well, there's only like a minute left anyway. I'll have to fix it. Okay, are there any questions about this derivative here? Okay, we're not going to do the next problem. I just want to talk about it briefly. We'll do it next class. It specifically tells me to use logarithmic differentiation to find y prime in question 7. Why is logarithmic differentiation a good plan? So I don't exactly, it's because, so a lot of you are getting there. It's a mixture of product rules and quotient rules. We can avoid that quotient rule by doing this and the product rules, but there is no plus or minus, and that is the key thing. There's no like pluses, there's no minuses. It's not e to the x plus that thing. It's not ln x plus that sign. It's all multiplication and division. That's why logarithmic differentiation is a good plan. Is it going to be necessary? Yeah, I think that is what you said, Bean. That's what I saw. Is it going to be necessary here or just useful? Not necessary is just helpful. Good, because there aren't x's on the bottom that have x's up top as well. So we're going to end today, and next class we will continue. We'll do logarithmic differentiation. We'll do, and then we'll move into the portion of the class that you guys just had on your mock test. That is all for today.